it was myself, Chris, and Shufei, and we took three-prong approach here. So the first prong was to have Shufei sort of upgrade the current blockchain code that we had in place. So I started off, I prototyped it, threw some stuff in there. Then we, talked about, all right, how could we improve that? And that's this pull request here. So Shufei added, he changed the header, he added transactions. I'll let him talk about that. Then my original goal was to actually deep dive on all this consensus, all the different consensus out there, and basically the ins and outs of blockchain, which I did. I spent a lot of time getting up to speed on blockchain terminology and technology. And Chris was going to evaluate use of this Aleph package or tool. I'm not even sure how you'd call it, for actually doing consensus. I'll let him talk about that. It turned out to be different than that because I spent almost 2 weeks educating myself on consensus and blockchain protocols and realizing that it was going to be extremely complicated for me to put together any sort of demonstration and testing scenario. Originally, we had planned on 2 weeks. So the pivot, Chris had suggested that I pivot towards analyzing Tendermint and its viability. So that's ultimately what I ended up doing. So I think I was to do the introduction, and then Chris, you were supposed to do your first presentation. Was that the game plan?
You're on mute, Chris.
Shufei's is faster, so I would suggest letting Shufei go first, and then I'll close it up.
Okay, so I'm going to stop sharing, and then Shufei, it's on you.
Okay, let me share my screen. Okay, desktop. Okay. Yes, open. Okay, sorry. Security. I don't have permission. Okay, give me a second. Okay, got it. Okay.
While Shufei is getting himself set up. So we've been working on this blockchain stuff for a little bit. We were scratching our heads and trying to figure out, like, where the hell do we begin? And we realized we just needed to, like, remove some of the burden of working on Piracy and trying to develop like demo level features. So we decided just to take a learning approach and just try to figure this stuff out and try things along the way. So the main goal here is to share what we learned during our hackathon and not necessarily a design or architecture review. So now that Shufei's back, I'll let him continue.
Shufei, are you able to share, or should I do some more filler stuff?
He's sharing.
He's sharing.
Oh, I see it now. Okay.
Go ahead, Shufei.
Take it away, buddy.
You're on mute.
Let me start. Okay. Yeah. Now we have the terminal. The left is called Alice. The right is called Bob. Okay. Now we could run the load Alice. Okay. Now Alice is run. Then we run the.
Can you explain to us what we're seeing here, Shufei, along the way?
Okay. What? Sorry. Okay. Then we run the node Bob. Okay. No. Okay. Can be too bad. Okay. Now we have the two nodes. Then we send the message. We create the block on the Alice. Then broadcast is block to the other peers. Then other peers will receive this block, then store in the file. Okay. Then with a hello. Yeah, block. Okay, and the left edit will add a new block to the file. The right, the Bob receive a new block. This is the block have the three parts. One is the head. Yeah, the second is the transaction. Transaction is include all the payload, all the message. For example, the hello JFrog is in the transaction.
Mhm.
Yeah. The third part is the signature.
Mm.
The signature. Yeah. Signature is the all the block's signature. Yeah. The header also include the parent hash. Parent hash is the previous block's hash value. Then yeah, then the timestamp, then the committer. This is the committer. Committer is who committed this block. Yeah, why we need the header, the structure? Because if we support the lightweight the load, they only download the header, don't include a transaction. You could verify this the block. Yeah. Yeah, now we only have one transaction in the transactions. Yeah. Okay.
Hey, Shufei, in this case, committer, is the committer a person like me, or is it the node that is committing?
Yeah, it's the committer node is the node. Yeah,
It's a node. It's a node ID, right?
Yeah,
not
node
not
ID.
the person. Not
Wait,
the
wait, wait.
person. Okay.
Yeah, node ID.
Wait,
Committer node isn't even a person node. It is just a part of the blockchain architecture responsible for making the final go, no go on whether a block gets into the chain.
And can we allow Shufei to explain his code, please?
I didn't understand. Okay.
Yeah,
I have one other question.
Okay.
How come there's two signatures?
Yeah, yeah, it's a good question. Yeah, the signature because the transaction and someone to submit the transaction. For example, now the transaction is submitted by the Alice. Then Alice give the transaction is a signature and the hash. Then the others will to combine all transactions to the transactions. Then commit this block to the blockchain. Then this is another signature. This is called who is the committer. Then is the signature is the committer's signature. So we need two different the signature. Maybe the transactions have the many signature. Each transaction have one signature. Then all the transactions have the committer signature to commit this to the blockchain. Okay.
Got it. Thanks.
Okay, thank you. I go to next. Then we could to add the mode block. For example, is the A. Yeah, it's the easy to. Okay. Yeah, you could look at the payload. Yeah, payload is here. Okay, sorry. Okay. Yeah. Okay. Yeah, you can share the payload is here. Let me check. Okay, then from the Bob could to create the block and to broadcast to the other peer.
The payload you're looking for is farther than Shufe. It's the 65s.
Yeah, the payload I think is.
No, you want the one lower, the one with all the 65s. Isn't that the A's? What's A in ASCII?
Yeah,
Right there.
40 hex or 65 decimal.
Yeah, I think I just find there's a problem. Yeah.
Oh, yeah, capital A is 65 decimal.
Yes, I see. Yeah, okay.
Is there down, but why do we have two payloads? Is there down, Shufei? If you go down more, yeah.
10 lines.
10 lines from the bottom.
Yeah, you're where your
On the
mouse
left.
is right. Yeah, okay. Yeah, right there, right above that. Right above 2 lines.
Okay. Yeah, I don't. So sorry, it's not the clear. Yeah.
Two more lines there. There.
Oh, right there, I see it.
Transaction,
Down,
yeah.
down, 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 down. Stop,
There.
stop,
That one,
stop,
65.
stop, no,
Okay,
no.
Okay,
Yeah.
yeah, sorry. Yeah, sorry. Okay, yeah, then the Bob could send the transaction, send the block to create the block, then broadcast to the other peers. Yeah, let happy. Yeah, the new year. Okay. Yeah, then the Bobo is added the block, then to send to the Alice. Then Bobo could send the others. Okay, let me, for example, the BBB. Yeah, okay. We find, yeah, this is the committer permission is limited because we have the committer permission police. Yeah, now the Alice, we set the committer permission police is what when I started the command, if you look at sorry, okay, sorry. Let me go ahead. Yeah, we started. This is the commission police, and the Alice is one. The Bobo is two. The one is the is allowed the Alice could continue to commit, but for the Bob, he only must be at least the one block the apart to commit. This we give the different law, give the different the permission. Yeah, this is yeah. So this is the transaction should be sent to the Alice to commit to the block, but this transaction is under development. Now I not implement this part. Yeah. Now the Alice could create the new again. Then the Bobo could create. Bobo have the permission to create the new block. Yeah. It's the yeah. Yeah, that's all. Yeah, thank you.
So Bob has to wait every time if Bob wants to commit, he has to wait for Alice to do that first.
Yes, and Bob, you could to configure this. Yeah, Bob must be at least the one block to apart. You could configure to two block. Yeah, give the different the committer the police. Then use this part. We could to implement the simple the consensus algorithm. For example, we let the each loader have the same the permission to commit. So if we have the full loader, that block each loader have the have each loader could commit the loader one by one. Yeah. Yeah. Also, you could configure to, for example, this loader have the more the power of the committer. They also have the more chance to commit the block in the blockchain.
Yeah. Hey, since we are pausing, hey, I would just want to welcome Yotam. Yotam, welcome. We started a little bit early just from our stand-up, but you didn't miss anything because Shufei started the first thing and started showcasing how the blocks are committed, and that's the discussion we were having. And a bunch of this stuff is documented in a GitHub ticket on the project. So you will be able to follow that even after this. Okay.
Awesome. Thank you. Thanks for that.
Yeah. Continue, Shufei. Sorry.
Okay. Yeah. That's all. That's all the demo. Yeah. Any question? Yeah. Thank you.
I mean, I guess for now, I don't have any, it's just from what I'm seeing on the screen, it's hard to really see the clear breakdown of header, what pieces are in it, and transactions and what pieces are in it, et cetera. It's just from here, it's just kind of hard to see, but.
Yeah. Okay. Yeah, I don't implement the pretty format. Yeah, sorry.
Yeah.
Okay. Well, if you're done, then Chris, you want to go next?
Yes, please.
All right, Shufei, stop sharing.
Yeah, okay, give me a second. Okay. Okay.
You should have like a bar at the top. Yeah.
Okay, yeah, thank you.
Alrighty, so I actually have two demos for you guys. What was it? Blockchain. There it is. Right, so this was our initial mission statement. We just want to create a simple blockchain, and We had a couple little demo requirements, and I found Rust to be absolute trash as a C++ developer. It reminds me of my mom when I was 14 going off on like scuba diving, and she would chase me down with floaties. I feel like the Rust compiler is my mom with floaties. I know how to memory manage myself, so I don't really need floaties to go swimming with sharks, but that's just my 2 cents on the matter. But that's not a way to make good decisions. So I really wanted to take the time to figure out, if I had to make a blockchain in Rust, what is the best way to do it? And I had been toying with this for quite a while before we even started the blockchain hackathon. And I found one particular option, which is this library. It's actually a framework called Substrate. And this is probably the most popular framework that's in Rust for building blockchains. And it has all your usual fun stuff going on. What I found most interesting is the Polkadot. So in current blockchain infrastructures like Bitcoin and Ethereum, there's no way of connecting the two. And Substrate is based on this Polkadot, and Polkadot is based on Substrate. And it allows you to write parachains and distributed applications that work on multiple blockchains at once. So this library has been quite popular, and like there's 150 projects are building on Substrate, and you can read all their case studies. They have quite a few different things. And it's incredibly flexible. And there's been a lot of interesting work that's been done on top of this.
Chris, can you explain to me, you were talking about parachains. Can you explain for the audience at home about parachains and why we would even care?
Yes. So having one decentralized network is really hard, but having a decentralized network that's built on other decentralized networks is really harder. And there's this notion that you can create checkpoints between your blockchains and commit and refer to each other. And it gives you, I think the easiest way to put it is you're doubling down on the decentralized networks. So each chain is helping ensure the other one. I'm not the expert, but that's my super high level conceptual understanding thus far. And I'm guaranteed that's going to change as I learn more. So I will open up one of my terminals, and we can already see.
Before you move on, can you help me understand how the concept of the chain of chains fits with what we're doing?
It doesn't. The whole point of this hackathon was to work outside of the scope of Piercia, and I'm just sharing what I learned.
Okay.
So this Substrate framework is an entire blockchain ecosystem. And you can grab their example and get started with an entire network consensus. They have some really fun implementations. One of them is called Grandpa. Another one's called Aurora. Aurora is a proof of authority round robin, which I thought was really interesting for our use cases. And from Christian's research, it seems like it would be one of the best fits for us. And right here, you can see one of these nodes running. And you can see it's doing things like pre-sale block proposal with a hash, a parent hash. It's importing its block into its chain. It's starting its own consensus, but there's no one else in this network, so it's going to agree with itself. And we should see a finalized message. Oh, there's one above as an example. So you can see that it finalizes its own blocks. What I love the most about this framework is it has already built into it a standard RPC, so a remote procedure call execution system. And you can do super fun things like run an entire UI on top of it. So you can see I have a Substrate node. It's called development. This is the WebSocket. You can see I have 436 blocks and 434 have been finalized. I'm currently signed in as Alice, and she has what I wish was my bank account. And you can see we have others like Bob, Charlie, Dave, Eve, and Freddie. And you can do a ton of fun things with all of this. So let's say we want to do a transfer. I can copy Bob. Actually, let's take Eve because Eve is poor. So let's give Eve some money. And we'll send her a really big number and we'll submit. And you can see it's doing transaction in status, in block. If I flip to the terminal,
Oh, you gotta
Yeah.
scroll down, Chris. Scroll down.
Oh, thank you so much.
No worries, buddy. I'm here for you.
But I missed it now. Somewhere in here, there should have been a transaction. That's all right. We see we got new blocks finalized. And here you can see that it was finalized in a particular block. And in our gorgeous WebSocket UI, we have Eve now has a lot of money. I wish I can send that to myself.
Well, she has a lot of crypto token, whatever that is. Now, if that was Dogecoin,
Oh yeah,
Hey,
I want some of that $36,000 Bitcoin in my account.
So my question is, from the transaction that you made, how do you relate? Like, let's say you're looking at the log, the one on your command line. Is there a way to find and from here what is going on in the back and which transaction actually? So how do you debug this? Is what my question is.
No clue. The whole beauty about this framework is it does everything, and it's so widely deployed that you don't really need to debug anything.
Oh no, I don't trust those. I don't trust those things that don't let me
in the
debug.
logs. You can find it in the logs, but obviously there's a ton of logs, and it's very difficult to find anything. So
Yeah.
it did give you your hash, Chris. If you look up the hash from that web page and then you just go like do a search inside your
yeah.
your terminal, you might be able to find it.
So this is where the thing gets really fun. We have something called the palette interactor. So we can actually go and use some of these to try to find things. So if I pick balances, I have callables, and I can do like different inspections onto the blockchain. So I can force transfers, I can unreserve balances, I can change things. And there's
What about query, Chris? Can you query any transaction?
Yes, you can. So
Like-
there's different interaction types. I don't know how to pronounce this word, so I'll let somebody else.
Extrinsic.
Extrinsic.
Ugh. I'm not even gonna try that. And then here we can do queries for different things, right? So we can do
So how do we
balances.
query this last transaction?
Yeah, I think the balance is obvious because it shows up in the thing, but I want to make sure that that actually happened in the bank account. So I would like to see it in the logs.
Well, you
can
should
see
be able to look at that sender now and look at their wallet, and it should tell you exactly what they have, right?
I know I can look at their wallet, and that's what the top table shows, and the wallet reflects. But I want to make sure that that wallet doesn't have fake money, right? That
So-
money actually came from somebody's wallet, and I want to see that transaction because I really need my system to tell me that transparently that is what happened. Otherwise, that money is just being created out of nowhere,
Yes.
right?
So here in events, you can see the different transactions that have gone through our blockchain so far, right? And you can see here there was a balance withdrawal of a certain amount, and this here is the staking value, if I'm not mistaken. And we can see there's a system account being recorded. There's a balance being endowed, and you can see the amount here. So you can see this money is going to this account, which MAW,
Is easy.
right? And then you can see the transfer, and you can see both accounts. This one here is probably going to be Alice, UTQY,
Okay.
and you can see
Yeah.
the amount going through.
Got
So
it. Okay. There is
The
so there
UI is a
specific-
lot easier to use, and that's the
Mhm.
beauty about it, is that you can easily pull and request information from the blockchain.
Do you know if it supports the idea of associating arbitrary attributes with accounts in addition to a balance?
Yes, it does. That brings me to my next point. So
Yay!
we'll do an extrinsic, we'll do nicks. So this is the palette I wrote. I wanted to give my accounts nicknames because I think that's fun. So we're gonna force the name, and we're gonna pick Charlie. And I think Charlie's I don't know, a rubber ducky. And when you think of that, you can imagine the cute little rubber ducky here. You go squeak, squeak, except he can't squeak because my dog would kill me. And we will do it signed. And then the transaction is ready. Can we, oh, I was too slow. But you can see here, our events have moved. So we have the pay fees on. You can see that going through. You can see it being withdrawn from the account, and it's being finalized in the hash. And then we can go to query, we can pick mix, and then we can.
Oh, so you just added another block that just had that key value pair.
I asked for a transaction that got recorded in one of the blocks because the blocks come out at time frames.
Okay, but either way, there's a new block now with this key value pair. Got it.
Yes. And
You should be able to look for rubber ducky or something, right?
whoops. Bad origin. Uh-oh. I broke something.
Good job, Chris.
Anyways,
That's how you know it's a live demo.
Yeah, exactly. That's how you know I forgot what I was doing. But you all get the gist of this, right? So
Yeah.
you can add your own palettes, you can inspect, query, RPC
What is-
constants.
Describe to me what a pallet is, because in my understanding, a pallet is a piece of wood that I put some heavy stuff on and ship it.
That's exactly what a pallet is. So in Substrate, they have their own terminology, their own lingo, and pallets are the things that carry blocks. So or transactions, it's a little confusing. So you write this idea of a pallet, and a pallet is used to move things around, right? So you stack stuff on it, you move it around, and that's what a pallet is in Substrate, except instead of it being Amazon parcels that I probably shouldn't have spent my time buying, and it's your blocks and whatever transaction data goes inside of those.
Okay. So how does the search work then?
So because each node has its own local copy of the blockchain, it's able to go through its index of those blocks and easily find the information that it's looking for. And each pallet knows how to look inside of the chain for its information.
Okay. Handy if it could work.
Yeah, I apologize.
Looks
for
very
going-
interesting.
So my question is connecting Shufei's work and this. So Shufei's work helps us actually commit to the blockchain. So this will sit on top and provide the consensus algorithm.
No,
The other way.
Okay.
So this
The
does
other way?
absolutely
Okay.
everything. So this is doing the blocks, the transactions, the consensus, signature handling. It does absolutely everything of the blockchain, all the framework, all the ecosystem. Adopting something like this forces you to work within their model.
Yeah. So this is the ORM for the database, if blockchain were a database, right?
Mm,
I'm not sure I would call it an ORM, but it is obviously opinionated, and that's okay.
Yeah.
Especially when you're starting off, using an opinionated framework is a nice guide rail.
Yeah. This likes to hold your hand and make things real easy. However, where this
It only took Chris 4 weeks. That's how easy it is.
that one.
Hey, maybe while Chris is doing that. So Christian, my actually question is, how do these two things come together? So when we make a decision, let us say if we decide on Substrate, then do we not need what Shufei did already?
No, they are meant to go together like macaroni and cheese. So Substrate is going to carry the payload, the block that we came up with, that Shufei came up with, right? Me, Chris, and Shufei brainstormed on it. Substrate is going to take it and carry it. Substrate can take whatever payload you want, right? So in Chris's case, he kept it super, super simple because he knew, Shufei was working on, something else, and he had fair confidence that it could just carry the torch, or, light the Persia fire, or whatever, come up with your own Persia analogy. So no, these are complementary in every respect. It's anticipated that these would go together.
Okay.
So that is a perfect segue to my next demo. So we had a meeting with Steve, and we went down some of like the MVP requirements. And one of them in particular is that we cannot have tokens or incentives. And for those of you who haven't been following the crypto space, as we've so unfortunately been doing, companies like even Facebook have lost tons of supporters and corporate backers on their cryptocurrencies to the point where they just shut down the project and they're selling the intellectual property for it. Substrate is made to build cryptocurrencies and cryptocurrency-based applications. So you cannot remove the idea of a balance from this framework. And once I had that epiphany, about halfway through our hackathon, I decided to switch course. So I will kill this little guy. Tabs. And I will grab a second demo. So instead of using an entire framework and ecosystem that gives us everything, I wanted to do something that would actually build on top of and slide next to what Shufei is working. So I found a fun cryptocurrency project that publishes their consensus algorithm as its own standalone crate that you can build on top of. And because this is Rust and because it's decentralized, everybody uses libp2p, which made my life real easy. So I have this fun little run blockchain script. Boom. And all it does is it just runs, I stuck it in the Piercia node, but I actually butchered everything inside of it. It'll just run 3 different nodes. And the way I implemented the algorithm here is that it does a round robin of proof of authorities. So if I go here, main, I have a predefined set of authorities. There's 3 keys, and I have 3 nodes that will be started. Oh, golly, Rust is garbage. And
Tell us how you really feel, Chris, and don't hold back.
so while that takes 3 minutes to run, I'll just skip to the logs that I have saved. And we'll start at the top. I will make this a little smaller. I can make Control Plus, is it?
Wow.
And I have to move the zoom stuff out of my way. Try to make them smaller. So you can see here we're starting. We're recording new authorities. So we got node index 0, 1, and 2. This is how I start my nodes. And a bunch of discovery events. And then the current block author is 1. And he sends a message to everybody. We receive messages. Dun, 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 dun. And then we get to the beautiful point where we do adding block number 1. So index 1 adds block 1. So he goes, he updates his chain, and then we receive block number 2 from peer index number 2, and we record this. And as we move along, we can see we got 6 from 6. And this is where it gets interesting. We're sending new consensus messages. So we can see here, signable full unit. I don't know what some of these terms mean, but they're there. So this is round 0, and the creator was node index 1. And we have combined hash. Dun, 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 dun. And we have a beautiful signature. Oh, golly. And I picked the Edwards key because that's what we're using for the node index. So our node index is our key, which is our peer ID, and everything matches together.
Hey, Chris, when does the consensus message get sent? Does it, after node 1 gets its block, it decides to try to start sending consensus, or is it after a certain period of time?
So I hard coded it to 5 seconds because that was convenient for myself to see the blocks and then see the consensus messages. And the way it works is that they go by checkpoints. So if I've seen 3 or 4 blocks, I have a particular hash, which is the state of my blockchain. And that hash is what the consensus messages are being referred to. So if I go the control hash, parent hash, and combined hash, here it is, combined hash. So this is the hash of the state of my blockchain. So all the link list of nodes and blocks are saved as one combined hash. And this is what the nodes are agreeing to. They're agreeing to the total state of the blockchain.
Got it.
Thank you for that absolutely beautiful question. So you can see here, we're verifying messages and signatures from each other. We're doing some weird stuff that's part of the consensus algorithm. You can see this is coming from the underlying, oh, it started. Oh, garbage Rust code. And it's running. Woohoo. And the fun part is when we get to highest finalized. So as the consensus goes, you can see here a new unit and extender, round 5. It has a different hash. We have round 6. And then we do adding to store. So we're saving the new state of consensus from our blockchain. And here you can see we finalized round 2 with a certain head. So the consensus went between all 3 nodes. They passed their messages back and forth. And they all agree that the current head of the blockchain is this combined shell. And here you can see they're agreeing. So they got 10, and then they send some more messages. I scroll a lot.
Did how the consensus scales when you get to a larger number of nodes?
You can read the white paper. They have a lot of weird math about how this works and how they do everything. And
Hey, please post a link. So I'd like to read it.
alrighty, I'll do that after the meeting. So this consensus message, where are we going? Oh, here we go. Some more consensus messages. We're adding new blocks, verifying them. And here you can now see that they've now agreed on 75 blocks. And if I scroll to the bottom, we should see 100. Woohoo! We made it. So I hard-coded my sample blockchain program just to stop at 100 blocks because that was reasonably fast. And this implements quite a few different tricks on how to make them secure and how to make them optimal, most of which I still don't understand because this stuff is super ridiculously complicated. But I have a fully working consensus algorithm that's backed on a proof of authority list of signatures, and everything is cryptographically signed and verified. So we can send messages, store transactions, and save everything. What I did not do was the content of a block. So right now, my blocks, oh, Zoom is terrible. Blockchain, block.rs, chain.rs. Here, new block, I just generate random data. So all of what I've done here is orthogonal to what Shufei has done. Shufei has done the block structure, what it means to have a transaction, block headers, verified them, how to keep everything in order. I did all the consensus and network agreement side of things. So they complement each other quite well.
And this runs over libp2p, right?
Absolutely. So this is all libp2p nodes. I used a different type of message channel that they support that no one else has used in the team before. So I used their request response model for messaging, and I found that really good and convenient. Yeah. So that's my second demo. A lot less flashy than the first, but more appropriate to us. This is no cryptocurrency, so there's no worry about the US Federal Reserve suing us for bajillions of dollars to shut us down. But we have consensus and we can agree on the state of a blockchain, which is.
We had, I think we had discussed, Chris, that in the case of where, you know, we're leveraging any technology where it basically has the concept of money, that we basically set transaction costs to 0, right? Gas of 0. Yep. And that way, sure, there's a currency floating around, but you can have as much or as little as you want. It makes no difference.
Very few people are trying to use blockchain without cryptocurrency. So those are very few and far apart. I did not find anything concrete or meaningful. So finding a consensus engine and being able to build on top of that is probably going to be our best bet for meeting our current MVP requirements.
If how do I put this? The spirit of what is desired versus what's actually there, right? Like, so yes, in the bowels of the code, it refers to monies, right? But that's the technical implementation. The spirit of it is that nobody makes any money in the process. There is no exchange of value. And so if everything costs zero, there is no mathematical exchange of value. So I'm kind of a fan of getting one-stop shopping and then just setting transaction values to zero. I think that means the spirit, but that's for a later debate.
Yeah. So something like Substrate would be very good at doing that, right? This left BFT consensus algorithm has no value whatsoever. There's no token, there's no currency, there's no weights to anything, there's no exchange, there's no transaction fees.
Yeah, is that pinned somewhere where we can clearly see that we have made gas zero and everything? And if somebody forks a repo and creates a Persia node with gas equal to 20.
No, so again, there's no Persia nodes here, right? This is just a proof of concept of a blockchain. And I stole the one Rust project that was already on my system, so you can ignore the word Persia.
No, I understand.
But
I understand
there
that
is
part.
no gas in this. There is no gas. There's no weight. There's no value. There's no token. There's no currency. None of that exists.
I agree, but we said somewhere that we set gas to zero.
That was me ad-libbing that if we were using Substrate instead of Aleph, that one of the ways we could meet the spirit of no financial incentive would be to set the cost of a transaction and the reward for a transaction to zero. So
where would we set that? Would that be in?
We would hard code it.
Would that be in Substrate or would that be in?
That would be in our Persia implementation of whatever palettes we invent to do whatever we need to do.
Okay, in the palette. Okay, so that's the So if I were to look there and if I find a value that is not zero, then I know that somebody has tried to change the balance of this network, right? Okay.
Hey, Chris, was there anything weird at the crate dependencies that you ran into with this, or is it going to fit into what we're currently doing with Persia pretty easily?
This will not fit in with Persia no matter what. So that's even easier. This doesn't really follow any of the architecture. This doesn't follow anything about Persia whatsoever. I really just threw that out the door, and I just wanted to solve the problem of how do you do a blockchain in Rust? And then when we got the new requirements from Steve, I adjusted my implementation for that. So
okay, I think that is the next step, to figure out if this can fit in Persia and what are the challenges and what are the things that we need to be aware of.
I'll take a look at the white paper, but what I'm hoping to find is that this is something that we can build on top of. Because this does
that was my hope. That's my intention. How do we incorporate this into the project? Shufei, Christian, and I have scheduled daily meetings. We're going to talk about these things, try to figure it out. We need to try to take Shufei's work, my work, mesh it all together somehow, come up with something meaningful. So that's absolutely the next step. And that's what we've been talking about amongst the three of us as we were wrapping up our hackathon.
My only comment would be, don't just come back in 3 weeks and add hundreds of lines of code. Try to do it iteratively and show us small improvements.
Yeah, so that obviously there's a challenge with that because adding this in the first place is going to be a few thousand lines of code, right? It's hard to avoid that when you try to add an entire.
Yeah, but this is kind of like a fork, I think, in a lot of ways, right? You have to go off, do a MVP, see what we can actually implement. So is that all of the presentations on the blockchain hackathon?
Yes.
Chris? Okay, so first I want to thank everybody. Sorry, I'm off camera now. I want to thank everybody for like the hard work going through and exploring different options and trying to find things which might be interesting technologies we should explore. I think this is Chris was kind of alluding to this, and we had a longer discussion about the reason why this is critical for the project, but we need a distributed transparency log, which will back the network so that we can verify the integrity of all of the artifacts which we're storing. And for some of the reasons Chris mentioned and others, we don't think it makes sense right now to try to actually do a incentive-based model for this, mostly from like a regulatory and legal standpoint. That said, the best examples of distributed transparency logs right now are blockchain technology-based things. And it's a great application of the technology if used correctly. So I think that this gives us some different options for how we can do this and integrate it with the Persia project. And I know that, you know, we're trying to figure out the roadmap and the MVP for getting something released. But when you look at the value we provide as a project, it's great to integrate with the cloud native ecosystem and show we can like exchange packages and Docker images to have a peer-to-peer system. But if there's not a fundamentally secure transaction log and backing for all of this, then like the story and our ability to kind of explain the value of this goes down significantly. So I think that having this problem worked out for the MVP is really critical. So thanks everybody for the great work and prototypes and stuff which you showcased. I know a lot more work went into it than what you showed us. And I think we don't need to decide here on the right implementation, but this gives us a bunch of different options and like great things we can research. And like as our guest from who's outside the team right now, Yotam, what were your thoughts just kind of seeing the directions and stuff which the team showcased today?
So it was interesting. I mainly tagged along to learn. The Persia project by itself is something very interesting, I think. So, but I still have some catching up to do to get up to speed to what's been done so far. But it was interesting. Thanks for the presentation.
Hey, Yotam, thanks for coming to our meetings. And you have been through a few of them. I saw you in a couple others. Are there things that we can do to help you onboard, start contributing in whatever sense you want to start contributing? Let us know. If you need a session to onboard, we can arrange that. Anyway, our stand-ups are at 11 a.m. PST, every 11:05 actually, every day. So drop in at any time, and then you can say, hey, I'm ready to start today, and we'll spend like half an hour with you to get you started, set up your machine, whatever it is that you need. We can help you.
Sounds great. I need to see in terms of bandwidth if that's something that I can take on. I don't want to, jump in and then don't have enough time to actually do the work.
Yeah, and we also have some things in backlog which are a little bit longer term. So you don't need to, you don't have a timeline right away. So you can start with that, and there are some good first issues where you can get started for small things, and then you can start ramping up.
Yeah, and
so whatever
just from a higher level. So for other companies we're talking about who are interested in participating in the project, there's a bunch of different ways to engage with the project besides just developing it. So we do want companies to independently kind of run nodes and participate in the network once we launch the project. So if your company Resilien's interested in that, we can discuss. We want folks who can participate and contribute architectural guidance, security guidance, and it can be both attending meetings and giving feedback, but also submitting PRs or responding to PRs in the system. And even if they're non-technical contributions, that helps a lot. Or even if they're technical but not code contributions, that helps a lot. And of course, if you have the bandwidth or someone else in your company is interested to actually develop on the project, we'd love additional contributors as well. So we have folks from a variety of different companies who are participating in the effort. And I think that's also like the deepest level of contribution, but like we're welcoming different forms of contribution based on what makes sense for individuals and their companies.
Sounds great. Thanks.
I want to say thanks to Chris and Shufei for their effort, especially Chris. He dealt with some crazy frustration between Rust and these libraries, and good job.
Thank you to all the participants for making this such a delight. That was absolutely a highlight.
Yeah, thank
And
you.
you seem delighted, Chris. You absolutely seem thrilled.
Especially when I solved my off by 1 index, because I started my index at 1 instead of 0, like a rookie junior. That was
rookie, bro.
yeah.
That is more human. To start at 1. So one thing, I was trying to give access to Yotam for the blockchain ticket, and I realized that it was created in the old repo Persia documentation, and I had a hard time moving it. So I'm moving it, but I'll do it after the demo. So if you're looking, just go to the project board first, and then go to the new ticket. It will have all the contents, and Yotam you'll get access directly then. And yeah. Okay, I think that's it then.
Yeah.
Right, team. All right, awesome work. Thank you, guys.